anaerobic lagoons are often used in sewage treatment facilities in developing countries. They can be constructed and maintained at low cost, but they are not sufficient for achieving a satisfactory quality of treated water. On the other hand, sewage treatment facilities in Japan or developed countries use advanced technologies to obtain high-quality treated water. Their drawback is high construction and maintenance costs. Metawater has developed the pre-treated trickling filtration system to meet developing countries' need for a sewage treatment system with low life cycle costs and high treatment performance. With low LCC, this pre-treated trickling filtration system provides satisfactory, stable water quality. The features of this system include low power consumption for treatment and low maintenance costs. It is also very compact. Fully automated, the system is simple to operate. Unlike conventional activated sludge processes, it does not require adjustments by skilled workers in daily operation. Let's have a closer look at this pre-treated trickling filtration system. The pre-treated trickling filtration system is a combination of 3 wastewater treatment components: a floating sponge filtration system, a high-rate trickling filter system, and a final solid-liquid separator. The floating sponge filtration system provides filtration with special filter media to remove solid SS and BOD. Influent, so-called raw water, comes into the treatment plant from domestic households through sewage pipelines. It then flows into the tank from its bottom. Solids are removed as they flow upward from the bottom and pass through a filter media bed. After removal of solids, the filtrated water is sent to the next step, the high-rate trickling filter system. The filter media consists of tiny sponge-like objects made of special material of small density that float in water and are highly resistant to adherence of sludge. The media almost completely removes solids that are 100 micrometers or larger. As the filter media bed becomes clogged, the water level on the inflow side rises. When this is detected, the system triggers backwashing of the media. Backwashing occurs when the high-speed flush valve in the bottom opens. The washing water above the filter media flows downward to wash out captured solids. The wastewater with the highly concentrated backwashed sludge goes to the sludge treatment process. This process can effectively achieve SS removal efficiency of 55% and a BOD removal efficiency of 30%. This helps reduce the subsequent load on the next system, the high-rate trickling filter system, and prevents clogging of the spray nozzle by solids. The high-rate trickling filter system removes soluble BOD further from the filtrated water by the former process. Filtrated water supplied to the high-rate trickling filter system is sprayed by a rotary sprayer over the carrier packed into the tank. Soluble BOD is removed by microorganisms in biofilm attached to the carrier. Water is treated in the high-rate trickling filter system, and sloughed biofilms in the effluent are conveyed to the final solid-liquid separator. The carriers used in the high-rate trickling filter system are made of plastic and have a length and diameter of about 1.5 centimeters. Their surfaces are finished to a coarse state to facilitate attachment of the biofilm. Their surface areas range from 500 to 1,000 square meters per cubic meter. The trickling filter process does not require air to be supplied by a blower or any other device that would consume a significant amount of energy, as is the case with a conventional activated sludge process. Oxygen, which is required to decompose organic materials in the wastewater by microorganisms, is in the air or water. It is supplied spontaneously to the thin biofilm on the carrier surface. As the microorganisms grow, any excess biofilms are detached by spontaneous sloughing and consumed by various microorganisms and insects above the food chain in the wastewater. Thus, this system has the merit of only a small amount of excess sludge production compared to a conventional activated sludge process. Along with odors, the conventional trickling filtration process faces the problem of filter flies when the larva hatches in the tank. To solve those problems, the high-rate trickling filter system enables periodical cleaning of the carrier bed. Cleaning facilitates washing of excess biofilms, sludge, and larvae of flies sticking to carrier surfaces and between carriers. Cleaning also helps eradicate insects and prevent odor emission. The method used to clean the high-rate trickling filter system is to fill the interior with water by closing the drain valve. This ponding can suffocate fly larvae and adults. Then, compressed air is supplied from the bottom to scour the carriers for several minutes for cleaning. Sludge and remains of insects captured between carriers are detached when the carriers are bubbled during cleaning. After cleaning, the valve is opened to recover the detached solids, which are sent to the sludge treatment process. This cleaning process is done about once a month. The high-rate trickling filter system can achieve SS removal efficiency of 40% and BOD removal efficiency of 70%. BOD can be removed without aeration, while cleaning suppresses generation of flies and odors. In the final solid-liquid separation, filter media is packed in the area around the overflow weir in the rear of the tank. This process, which requires very little space, achieves improved removal efficiency. The filter is made of plastic filter media, which, unlike the carrier material used in the high-rate trickling filter system, has a smooth surface that resists attachment of biofilm. Effluent from the high-rate trickling filter contains sludge in the form of sloughed biofilms. The sludge can be removed to a certain extent in conventional settling tanks. On the other hand, the final solid-liquid separator has the media bed arranged around the overflow weir. This demonstrates much higher treatment performance and makes it possible to minimize surface area. The use of smooth media with high porosity ensures extremely small filtration pressure loss, with the difference of elevation needed for filtration limited to only a few centimeters. The filter media bed becomes clogged as the operation continues. The cleaning process is performed when this occurs. This cleaning sequence is executed according to a timer setting, or when the rise of the water level on the inflow side is detected. For cleaning, the channel is switched from the treated water line to the sludge drain to stir media in the bed. Then, flowing air is supplied from the bottom. Since water keeps running, draining continues during stirring, and solids are washed out from the media into the sludge treatment process. Bubbling is done for about 10 minutes. After the flushing, the media is free of any fouling, and the line is switched back to the treated water side. The final solid-liquid separator can effectively achieve SS removal efficiency of 70% and BOD removal efficiency of 50%. The use of filter media helps reduce space while maintaining the treatment performance per unit area. The entire pre-treated trickling filtration system can remove approximately 90% of SS and BOD. Compared with the conventional activated sludge process, this pre-treated trickling filtration system has very low power consumption, is very easy to maintain, and the installation area needed is greatly reduced. Comparison in terms of SBR and OD also shows an overwhelmingly small amount of power consumption, remarkable space reduction, and easy maintenance. At Metawater, we are eager to see the pre-treated trickling filtration system developed with the know-how we have acquired over many years in the wastewater treatment field fully utilized, not only in Japan, but all over the world. We are confident that our pre-treated trickling filtration system, which meets the need for low LCC and high treatment performance, offers a new approach to sewerage projects in developing countries. We are ready to contribute to acceleration of infrastructure development and significant improvement of water environments. After over 2 years of verification experiments, this pre-treated trickling filtration system was awarded the Certificate of Technology Verification, the first ever in the International Technology Verification, managed by the Japan Sewage Works Agency.